Thanks for joining today on this Twitter space. Well, the idea of this space is to talk about how development is going, talk about the current testnet implementation and the next one that we are soon to release, and talk about some other details about how we are trying to have the fastest EVM possible on top of EOS. So basically, on this session, I will be talking about the existing architecture of the testnet, some of the limitations that we found, and how we will address them on the next release. Talk about a little bit of Silkworm. There is some project that we are integrating into Trust EVM, and the new protocol features that are coming in the next Mandel release. Well, as you may already know, at the beginning of the project, we have two options about how to implement this compatibility layer on top of EOS, how to implement Trust EVM. So one option was to implement it natively on Node.js, and the other one was to have a smart contract, a regular contract on EOS. Well, we knew that native was more performant since even if the runtime of EOS is pretty fast, native is still faster, but it's less flexible since when a new EVM version comes out, it forces all the node operators to update the software. So we decided to go the smart contract route, right? Knowing also that the WebAssembly runtime of EOS has a pretty good performance. And also it gives us more flexibility since, as you already know, EOS contracts can be updated with newer versions. Okay, so this is the path we take. We developed a C++ smart contract. Basically, we integrated EVM1. EVM1 is a fast Ethereum virtual machine implementation in C++, and the code base of EVM1 is optimized to provide fast and efficient execution of EVM smart contracts. But supporting EVM, the runtime is not only that. It's not only having an EVM compatibility layer. Is not only having the runtime ready. Developers need a way to access the current state and also querying for history. So this is where the Web3 JSON RPC comes in. Every Ethereum client implements a JSON RPC specification. There are a uniform set of methods that applications can rely to query for state information, to send transactions, etc. And since the state of the EVM, as is a smart contract, is persisted inside the EOS state, one possible solution that we thought was to map every JSON RPC request to a query of the EOS state of the EVM contract. But it's not that simple, because there are some specific calls on the JSON RPC specification that need access to historical state, right? For instance, you can query, like, I want to know what the storage of this contract at this position was, not at the head block at the current state, but in the past. Or also you can query a specific balance of an account, also historically, or you can execute a transaction and see the traces, but you can execute that transaction also at an arbitrary block height. So what we decided for this release of the testnet was to use a regular Ethereum client to serve those JSON RPC requests. So basically, what we are doing right now is we have the EVM runtime contract on the chain, and after the transactions are executed on chain, we extract them from the EOS blockchain, from the Jungle blockchain in this case, once they have been applied, and we feed them to an Ethereum client using the peer-to-peer wire protocol. So basically, we have a get node, the, one of the regular Ethereum clients, that is receiving all the transactions that has been applied into the EVM contract on the EOS blockchain, on the Jungle blockchain. Um, and and this works pretty good, but we have some limitations with that design. Um, so to simplify the architecture that we have right now on Trust EVM, which is running on Jungle for testnet, is we have the smart contract, which is the C++ contract using EVM1. We have a separate service. We call them we call it the translator service that extract the transactions from the blockchain and feed them to a get node. This get node is the one that exposed the JSON RPC interface to the world, basically the one that you are using when connecting with MetaMask. Basically, you are pointing to one of those Ethereum nodes. And then we have, well, a TX wrapper that basically handles the incoming transactions and wraps that transaction into an EOSIO TX transactions and push it to the blockchain, to the runtime contract. As I was saying, even though the architecture works fine, it has many moving parts. So we started thinking about having a simpler and more integrated, from the perspective of a node operator, like a more integrated setup. And this is where the previous design of the of EOSIO comes really handy. One of the cool features of the EOS node program is that it was built using AppBase. AppBase is a library that provides a basic framework for building applications from a set of plugins. AppBase manages the plugin lifecycle and ensures that all plugins are configured, initialized, started, and shut down in the proper order. So basically, you can construct an application that it comes from a set of plugins. So basically, we can extend the functionality of the EOS node by writing a custom plugin that later a node operator can choose to enable or not at the moment of running his node. Okay, this is part number one, the thing that we can extend the EOS node functionality by writing a custom C++ plugin. In fact, today, there are many plugins, each one of them addressing a specific purpose on the EOS node. On the other hand, there is Silkworm. Silkworm, as many of you know, is a C++ implementation of the Ethereum protocol written from scratch that is based on the Erigon architecture. They are aiming to be the fastest Ethereum client while maintaining a high quality of readability of its source code. So it's a pretty awesome project that it's having a lot of attention right now. So, since the EOS node can be extended using plugins, and we have an Ethereum C++ client implementation that is heavily focused on efficiency, we decided to create a plugin for Node.js using Silkworm that will be the responsible for serving the JSON RPC request to the EVM. So now, when this plugin is ready, if you want to run your own Trust EVM node, you will just need to run the official EOS node with just this new plugin enabled. And you will be able to serve JSON RPC requests, or that you can use it for development purposes, or to join a testnet, or to join mainnet, or any other type of configuration that uses it. So this simplifies, from our perspective, this simplifies a lot from the previous architecture, since all the necessary functionality will be bundled together in the same EOS node. Also, if you think about like exchanges that wanted to list some token that it's on top of Trust EVM, we also think in the operations problems that having many moving parts for a specific deployment can have for the DevOps team. So having just one node with a known configuration, we think it's just a better architecture from the one that we have. So this is where we are going. And last but not least, I want to talk about the Mandel new protocol features. Okay, there are new protocol features in Mandel. For those of you who don't know, Mandel is the upcoming version of the official EOS node that will help us the execution of the EVM runtime. There are special kind of contracts that are bundled within the EVM at fixed addresses. That they offer a set of advanced functionalities that are quite expensive in terms of computation time. Most of these functionalities were already supported on EOS, like hashes and key recovery algorithms. So the EVM runtime contract is just using them, linking to them, and using these specialized functions. But some others were not there. So we we had to implement them on at WebAssembly level instead of having a native implementation of those precompiled constructs. But the EOS.io protocol has a pretty nice feature that it can be extended by adding new protocol features that block producers can activate at their will. So we have submitted two new protocol features to the official EOS node that will have this new native function. Will add new native functions to the EOS.io protocol that will help speed up the calls to the Ethereum precompiled contracts that are bundled in the EVM. The Mandel release 3.1 RC1 have all these new features integrated and is started to be deployed on Jungle for testnet. So as soon as VPs update to the newer version and these protocol features are activated, the EVM runtime will start using them. So I think that we will have like a pretty nice combination between flexibility in terms of being able to keep up with the updates on the EVM, since we have the EVM implemented at smart contract level. But the things that are expensive in computation time, the Ethereum precompiled contracts, will be EOS.io intrinsics supported in these new protocol features. And for the RPC part, having this new Silverworm plugin integrated into the mainline EOS node will make life pretty much much easier to node operators that want to run a Trust node, a Trust EVM node. So well, this is the update on my side. We are pretty excited to be releasing this new testnet as soon as we can. And well, whatever question you may have, you can ask it at the end. Thank you.